leading Hexa-X2, coming also from Nokia, and pleasure then to welcome you all to our session today. And the session will be recorded, and the recording is about to start. And we have a rather tight agenda, as you see soon. So Carlos, please.
Yeah, this is Carlos Bernardos from UC3M. And as Mikko said, we have a very tight agenda. So I will quickly go into introducing the agenda. So we will start with some words from Arthur Ecker, co-chair of the Vision Working Group, trying to introduce the context of this white paper within the Vision Working Group. Then we'll move into some words from Alex from the 6G AI on the 6G global activities. Then we'll move to some slides on what is 5G, or what we believe is 5G at this point, from Toon on use cases, and from Håkon and Arthur on other aspects of the services of 6G. Then we'll have some words from on the technological enablers of 6G by Patrick and Krisa. Then we'll move into the summarizing or reviewing the 6G architecture view at this point from Omer and Martin. Then we'll move into a section of the white paper and try to summarize that section in the white paper on the major differences of 6G respect to 5G by Carles Behare. And then we will close with the section on next steps and standardization and regulation that from Valerio and Aurora. And then some final closing statements and potentially room for some feedback at the very end. And with that, I'll pass the floor to Arthur so he can introduce the context of the Vision Working Group into this activity. Arthur?
Thanks a lot, Carlos. Thanks, Mikko. I'm very honored to be here. I'm Arthur Hecker from Huawei Technologies here, speaking on behalf of Vision and Societal Challenges Working Group of the 6GIA that I'm chairing. So this was quite some trip, I have to say. I will not bother you for a long time, but we started this activity probably beginning of the year, so well more than 6 months ago, together with Carlos from the technical subgroup of the Vision Working Group. And that was requested specifically from 6GIA and the chairman of the board of 6GIA, because of course we need to present to the world the vision of the European industry, like what we think about 6G, how it should look like, what is important for us in Europe. And we have started this work. We were very soon, after some initial thoughts and maybe some initial TOC, which is still very well reflected here, we were joined by Mikko, and the things started going very fast, I have to say. Thanks, Mikko. Thanks, Carlos. It was a fantastic job organizing all these meetings and driving this forward. And what I wanted just to point out is really how great and informally we were accepting contributions. And, you know, we're not limited since a long time to the Vision Working Group, let alone to, you know, to 6GIA as well. So we welcome contributions from projects, from the project working groups, from the SNSJU. So it has been a great collaborative activity. And now that we have the overall result, it's really great to see it from my point of view. It's like a baby maturing and growing, you know. So with this, I would like to give the floor to Alex for the words from 6GIA and the global activities.
Thank you, Arthur. And just before that, there is still, on this welcoming part, a couple of slides overview on the approach.
Sorry about that.
No problem at all. And thanks a lot also for the cooperation. So yes, in this white paper, one thing that we are stressing is that we need a unified 6G vision worldwide towards single global consensus. We need one standard for 6G. We are on a good way towards that, and that is in the end kind of a win to everybody, and we get this global economies of scale. There is a heavy stress here on sustainability. We need to make 6G systems sustainable, any future technology sustainable, and we also need to see how we can use 6G to enhance the sustainability across other sectors of industry and society. We need to look at all these aspects of sustainability in addition to environmental, also social and economic sustainability. We see that 6G development is driven by key priorities like security, AI, energy efficiency, and ubiquitous coverage. And there is also a presentation here on the 6G-enabled services vision, highlighting the importance of interconnected and interoperable smart networks and services. You will hear more about relevant topics related to the upcoming 6G system, including advancements in hardware and radio technology, flexible network topologies, deterministic networking, network softwarization, digital twinning, widespread adoption of AI, as well as integrated sensing and communication. And as you can see in the next slide, with respect to this 6G architecture, there are many items that we are highlighting in the white paper. You can see them here, and you will learn more about them also today as part of the presentation. Then in the last slide here, as an introduction to this overall view, again, the emphasis on sustainability, trustworthiness, and inclusion. And then with respect also spectrum, where we need to stress that 6G needs a combination of frequency ranges to meet the coverage and enhanced capacity requirements and to serve the new emerging 6G use cases. At least 500 MHz of new wide area spectrum is needed per network, in addition to the reuse of existing spectrum, as well as wide enough bandwidth needed to meet the foreseen 6G capacity and coverage needs. And the spectral ranges, especially here being studied within WRC 27, are on this 4.4 to 4.8, as well as 7 to 8, and 14.8 to 15.35 gigahertz. So that is an overview what there is in the white paper, and then we finally get to the first chapter. This is by Alex, so please, the floor is yours.
Thank you very much, Mikko. Simply to say on behalf of the 6G Industry Association to thank everybody, Mikko, you and Carlos, that you were the editors of this white paper, and of course all the contributors. Now, my presentation is the least interesting one because it's the introduction. I will try to make some statements to help build the whole narrative. So if we can go to the next slide. I think the key thing that, even from the summary that Mikko said, the first thing was that we are targeting to have a global standard, and this is indeed the case. We are only fully aware about the IMT 2030 targets and how 6G is currently being planned to extend 5G. The topics that you see with the different bullets and boxes with the different colors are essentially what you can read in the white paper, section 3, in respect to technical enablers. So the white paper contains a lot of information on how these targets and work items from IMT 2030 are being investigated in the context of R&I European activities, and of course the identified topics for the 6G Industry Association. The main key areas are about integrated communication and sensing, and ubiquitous connectivity, and integrated AI and communication, as well as immersive communication, hyper-reliable and low-latency communication, and massive communication. Now, moving to the next slide, these are the targets for IMT 2030. But the activities in 3GPP have started. There has been a meeting of 3GPP SA1 last May, where the 6G Industry Association, together with SNSJU projects, have contributed the European view. In summary, we can see that key drivers to enable 6G have been identified at the following areas: security, AI, as we all know, AI is the main focus of all activities these days, immersive communication, sustainability and energy efficiency, ubiquitous and resilient coverage, integrated sensing and communication. I would like to make a special mention on the following fact. In Europe, sustainability aspects are of prime importance. And by sustainability, we are referring to sustainability for 6G networks and how the 6G networks can allows sustainable solutions for the verticals. And all this have to do in three different pillars, which are environmental, societal, and business sustainability. And of course, it's not only about discussing theory about sustainability, but also developing some frameworks that will allow us to measure the efficiency of the new mechanisms in the terms of sustainability. So starting from the HexX, the first HexX flagship project, and continuing to the HexX2, but also with a significant number of other projects in this NSJU, already efforts are undertaken to develop what we call as key value indicators. Moreover, just as fresh news, the IMT 2030 has requested input from various organizations around the world about the minimum technical requirements and the target values. And the Six Industry Association will be driving this and will provide this kind of input from the European perspective. Next slide, please. Now, the first chapter is about the global activities for 6G. And a recent survey paper published at the UCNC has identified the key areas in the various regions: Europe, China, Japan, India, the United States of America, India, Taiwan, and other survey papers from the literature, as well as the IMT 2030. In principle, all regions have or are trying to cover mainly the same areas. So with that, we see already some convergence in terms of target. And similar things are in terms of the intended KPIs. So as I was saying in the beginning, it's quite important to target for a global standard and have similar targets, because any fragmentation is not going to work in favor of any region. I would simply like to ask people that are not presenting to mute their mic, and Costa, if you can help with this while I'm presenting. Thank you, Costa. Okay, and then my last slide is that in the introduction, we are presenting what is the European perspective. In Europe, the European perspective in terms of R&D activities is the Smart Networks and Services joint undertaking. It's a joint undertaking between the European Commission and the Six Industry Association. So the Six Industry Association is the counterpart private entity that, together with the public side, are working to develop 6G in Europe. And of course, there are, from the public side, specific policies that the EC would like to see materialized. As an example, the sustainability, but there are too many others, like, for example, security. And at the same time, we have the priorities from the private side that the members of the Six Industry Association would like to see these priorities being implemented. We have structured this NSJU in different phases. Currently, we are in the second phase. And for those that may be not fully aware, we are covering the full value chain from the service provision to the architecture, core network, transport networks, integration of AI, wireless communication, photonics, the integration of satellite networks to the terrestrial networks. In this NSJU, we have been building experimentation platforms focusing on various areas, and the new recent focus will be on the cloud continuum, something that is a priority for the public side as well. And of course, we have been covering more than 10 different vertical industries in trials, working together with the verticals. So, in summary, this document is trying to capture what are the views from the private side in Europe, and I will pass the floor to the next speakers that will start presenting from the use cases, going to the architecture and all the other interesting things. Thank you very much, Mikko. The floor is back to you.
Yeah, thanks a lot, Alex. Yes, concerning the questions, they are mainly welcome in the chat of the call. And due to the packed agenda, there is little time here by audio. Then, yes, as you heard, so next item is moving forward with this what is 6G. And here then the presentation is started by Toon. So please, the floor is yours.
Okay, if you go to the next slide. So when you want to decide to determine what is 6G, then the first thing to do is to look at use cases. Use cases are then used to define requirements and KPIs that you need to fulfill these use cases. That's an important step in any new technology. We also see that in 3GPP, the first thing to do for 6G is to define the use cases and then the requirements that are there to fulfill those use cases. What you see here is a picture. That's the consolidated RNI view on 6G use cases, as was presented during this workshop on 6G use cases that also Alex was talking about. The use cases are based on what HEXAX has defined in last year. But then we took these use cases and asked various projects within SNS, but also national initiatives in Europe to provide feedback and review. And therefore, these use cases are slightly modified from HEXAX to take on board also these questions, but these kind of views. So there are 6 main use case families: collaborative robots, physical awareness, digital twins, fully connected world, trusted environments, and immersive experience. And for each, you have a set of detailed use cases. And one of those detailed use cases, the ones that you see on top, is the representative use case. And for each of the representative use cases, we have also defined key performance indicators. And for all these use cases, we also have looked at sustainability aspects, or HEXAX2 has looked at sustainability aspects for each of these use cases. So what is the impact on the economic sustainability, and the positive impact and the negative impact, and for each of the 3 sustainabilities, we have been looking at that. I cannot go to all these different use cases, but I can give one example of one of the use case families. And if you go to the next slide, then you can see here a artist impression of collaborative robots. So with collaborative robots, it's not so much the persons that are communicating, but it's robots that are communicating. And they need to communicate amongst each other because they are working together. Here you see collaborative work for robots in an industrial use case, but you can also picture collaborative robots that are maybe helping you in your house to hoover the floor and do the dishes, or maybe in a service robots in hotels or in the retirement home. So all these kind of robots, they do tasks together and they work together to do specific tasks. And for this particular use case, we also indeed have looked at all the different KPIs that you need, which are very much here related to the communication between the different use cases. With that, I give the floor for the next slide to Håkan, who will have another set of slides on what is 6G.
Let's see if my camera is also working.
Yes, we can hear you, Håkan.
Okay, good. So yeah, my name is Håkan Lansedhagen from Telenor RNI. This section of the white paper addresses towards 6G smart networks and services. It's taking an outside-in view on 6G and 6G enabled services, and it has 4 parts to it. First, we have some reflections on what we call affirming transition, sustaining 5G innovations into the next era. And then we also provide an illustration and reflections on what is sort of an overarching 6G enabled services vision. Then we jump into more specifically on interoperability. And we have one section on the ecosystem level and this approach towards business model innovation. So next slide, please. So the aim here is just to provide a broad and let's say overarching illustration for what we call a vision for 6G enabled services and interoperable smart networks. But before jumping into this, we also provide reflections on 5G and 5G advanced and how 5G is actually quite revolutionary compared to 4G in the use of software, new technologies, virtualization, 5G radio modes, and also slicing with core network slicing. And by this, 5G is providing offerings to a wide range of use cases and verticals. And on top of this, we anticipate that 6G will add to this, but also in profound new ways, as you will see in this presentation. And this gives new opportunities for new services and service enablers. And through this, we need to focus on the evolved service KPIs that will be even more important in 6G. So if you have a look then to the left and below the dotted line, there is the legend here. So starting first with 6G enabled networks. So there are several types of networks that is enabled and possible through both 5G and then with 6G. So local non-public networks, as well as logical private networks, and also public networks for special purpose. And here we can highlight PPDR or public safety communication networks, as well as public networks for general purpose. And the telco voice network is, of course, a very, let's say, archetypical kind of network. And there are multiple types of network systems. And indeed, this is in a context of networks or interoperable systems of systems. So again, ranging from indoor non-public networks to wireless sensor networks, to IoT networks, to PPDR networks, content delivery networks, IPX backbone networks, and not at least the internet itself. And also looking into high altitude systems and satellite systems. So next slide, please. So sort of the central dimension to this is indeed the 6G enabled user services and features. And then starting from the bottom here with the radio spectrum, also with physical communication medium and hardware elements. This enables fundamental capabilities like wireless and also fixed communication, but as well compute and identity management and certificates through eSIM, for instance. And the target is, and the ambition is, to offer a new innovation space through universal application services and new services, as well as targeted application services offered by singular or a group of operators. And to enable this vision, we need a lot of enablers and capabilities. And then next slide, please. So fundamentally, we have certainly connectivity services and specialized connectivity, as well as integrated sensing and communication. But we also anticipate compute, execution, and storage, and building further with software and app enablers, and also in-network embedded compute and storage, as well as embedded and further enhancement to edge compute. And service enablers can be in different spaces, like for digital twin, for augmented reality, virtual reality, machine learning, AI, and not at least security enablers. And we also, let's say, elaborate on the notion of logical network as a service. And this, we think, will become even a stronger, let's say, service concept with 6G, focusing on how to accommodate the needs by the different enterprises in the different verticals. And here we also promote the new service KPIs that we think should have a more prominent setting. So this can relate to service provisioning time, completion time, service input in various ways, also including how to coordinate multiple endpoints, not just single endpoints, and also ways of how to deal with service continuity and also in roaming context. And if you here it's also highlighted some of the service features like service continuity, mobility, roaming. So going to the next. The next dimension is wholesale services, and here the focus is services among the network and communication service providers. So peering relationships, direct peering, for instance, from one network provider to another, but also the context of smart network providers in the hub or transit role. And we need to consider this both in a local, geographically local setting, as well as national setting, and also international settings to reach, let's say, global connectivity. And this is at different layers, from interconnection at various levels, interworking at different functionalities, and also federation ways of structuring the collaboration. We also highlight here the notion of self-management and support services, and these again will be more and more important for enterprises to manage their own services and multiple roles that are involved. This can also involve virtual network operators, for instance. And here the different main layers like infrastructure, identifying transport, connectivity, data center, and cloud resources, and then stepping up to the cloud and communication layer with the related enablers and platform support services, and on top the various application layer services. Next slide, please. So let's say the top here identifies overall customer sectors and value creation spaces, and indeed we have to create value for someone, and we have identified these main categories, so consumer value, enterprise value, industry value, state and government value, and overall social value. And we also highlight here that we are driven by European policies and strategic orientations and the European, let's say, values and ways of collaborating jointly to achieve this. And for instance, these policies being derived in particular from the United Nations Sustainable Development Goals. And we know there are these three pillars: social, environmental, as well as economical sustainability objectives. So then moving on. So this illustration is sort of coming from the perspective of interoperability specifically, as well as requirements. And we have seen from above by Tool all the different use cases and use case families, and there are multiple requirements here. In order to have a holistic approach and overarching across multiple stakeholders, we have to let's say ensure that this is working jointly across operator domains. And this illustration highlights again the main sectors from consumer, business, industry, and mission critical. And then we highlight here that even consumer, let's say, sector need highly critical services. So to the right here, you see criticality and urgency levels. But we also, let's say, in this mapping between the left and the right, we also highlight that all of these sectors, they can have non-critical applications and services at a given time. So these things are very and highly dynamic. The point here is that the 6G-enabled interoperable smart networks and services working across the network operator domain have to ensure, let's say, that connectivity and specialized connectivity capabilities are aligned with the enablers and applications, and these need to function end-to-end. So we stress here that there is a clever harmonization needed to achieve this for this interoperable approach. of services in the next, let's say, in the new era. Yeah, please go on. So the last part of this section is looking closer to this new ecosystem level approach, and yeah, we are picking up from earlier work, and there is this white paper provided earlier by now I have to look at my notes. So there is this white paper on 5G and beyond 5G ecosystem business modeling, and here this highlights how important it is to indeed have an ecosystem level approach to business model innovation. And also we highlight that telecommunication is fundamentally a multi-stakeholder, not a single stakeholder, but a multi-stakeholder platform ecosystem, and that have some properties that we need to pay attention to. And this definitely calls for emphasis on a strong standardization approach and collaboration and alignment across the key stakeholders. And we know that that is not always that easy. We also, pay a little bit of attention to how regulation can impact us, and provide some thoughts on potential evolution of net neutrality. We see that a strong ecosystem awareness and enablement is needed to deliver on the environmentally and socially sustainable 6G solutions and the business model which are economically feasible for the stakeholders. And at the same time, business model evolution and innovation system thinking is needed towards incorporating sustainability and circular economy principles. And that we have to also, let's say, assess this to minimize negative impacts. The inherent ecosystem dynamics points to an iterative process as well, and to, let's say, facilitate continuously adjusting and optimizing the initial formulated business models, along with following the interaction with other ecosystem actors. Then, considering the richness anticipated by 6G enabled services and topologies, there is a need to develop business model blueprints that provides advice on likely beneficial business model structures and their relationships among the partners in the ecosystem. And these blueprints must consider both the horizontal dimension as well as the vertical dimension, and the geographical dimension from local per country to sub-regions to intercontinental and global perspective, and even multi-country regions. And as a concluding remark of this section, I just want to underline that key here is to understand the end user still, and the end customer perspectives and how value is created for them. And there are many dimensions so far, I think, that are still undeveloped. And the suggested 6G approach is an opportunity to improve and excel on these aspects. Yeah, thank you. Yeah, thank you.
Thank you, Håkon, and thank you, Toon. So then we can notice that there is quite rich discussion ongoing in the chat. And in terms of the presentation, we continue then towards the technological enablers by Patrick Rugeland and Krzysztof Papagianni, please.
Thank you, Mikko. So my name is Patrick Rugeland from Ericsson, and I'm the technical manager in XX2. And Krzysztof is from University of Amsterdam. And we'll give a brief overview of these technology enablers that are envisioned for 6G. So you can go to the next slide. So as you can see in this figure, there are many different categories. There were many different contributors help writing this chapter in the white paper, over 60 people. And the technologies are both low technology readiness level with forward-looking, and others which are targeting first release of 6G. So it's a mix of both short-term and long-term research on technology. So I will go through these different categories, with a few highlights from each of them. So we go to the next one. So the first one is on energy efficiency technology. And here we have two aspects. The first is network energy efficiency, and the other is on energy harvesting. The network energy efficiency, we see that it becomes more and more important for everything to be efficient and saving energy, and the mobile networks is no exceptions. And we see that it's important to break the energy curve. So even though the traffic is continuing to grow every year, we don't want to see that the energy consumption increases. And one important aspect for this is to enable efficient sleep modes. So even though you have maybe high energy consumption while you transmit data, it's very important that you can turn off equipment between the transmissions and have nodes and cells be in a sleep mode. And there is also possibility to use AR or ML models to predict the need for network management. So if you can predict when and where you need resources, you can also predict when you can turn equipment off. The other aspect is this energy harvesting. There is an ambition to have more simple IoT devices that can operate without power source or battery source, so that you can harvest energy from the environment. So this could be as simple as a solar panel, or you can have a wireless power transfer via the radio network. But in order to get this to work, you need to simplify the devices so that they can operate on extremely low powers. So certain functionality may not be possible on these simple devices. So maybe you need a simpler encryption or so. Or maybe you don't have support for mobility. For instance, if you have a sensor deployed, maybe you don't need that fancy functionality in it, but you also don't want to change the battery every couple of years on the device. Go to the next slide, please. The next area, which is very important, is security. And here in the white paper, we only scratch the surface on this. But one aspect is this zero trust architecture. So where you can have a dynamic trust assessment with continuous trust evaluation, where you can use network equipment that don't belong to yourself, but that you can verify that it doesn't leak your data or expose any breaches. And for this, you need a trust assessment framework so that you can, for instance, associate different intents of networks with a required level of trust. And at runtime, you can estimate the actual trust levels of different parts of the network. Another important aspect of the 6G security is this post-quantum cryptography. So the quantum computers are being developed, and within a few years, we may see equipment which are capable of breaking the current cryptography. And we will need to be able to counteract this with new ways to encrypt the data. Next slide, please. Another important aspect is deterministic networking. And this could be, for instance, for applications, for XR applications where you need a tight time synchronization between different users and the network. So that what you see in the XR application matches what you see in the real world. And here there are works looking at, for instance, adapting this IEEE 802 TSN specification from wired to wireless, including Wi-Fi and 3GPP. And the work has started a couple of releases ago. But there's a work on this TSN bridge adapter to integrate with different domains. But so far it lacks standardized interfaces, so it's difficult to have it widespread employment. Another important aspect for deterministic networking is to ensure the reliability. And here network redundancies can be important, to have multiple paths. And here the white paper discusses this dependability through redundancy through this IEEE 802.1 CB, which is known as a frame replication and elimination for reliability. which can be used. Next slide, please. Next, we have a chapter on various radio and signal processing innovations, which don't have very much to do with each other, but they show promising towards the 6G. One aspect related to this is different deployment technology. And here we see the need for this ultramassive MIMO, which is a natural evolution of what we have in this massive MIMO in 5G. So extend to a very large number of MIMO layers to increase the throughput. Another aspect are these reconfigurable intelligent surfaces, so that we can extend the coverage to different blind spots. And here we need to see the utility in real networks. If it's only in dedicated small areas where this would be, you can go back, one more, go back. No, there. If it's only in small areas where this would be relevant, or if it could be deployed in wide areas. There's also a lot of work on these high frequency technologies. So there's this promise of the sub-terahertz communication. And there's a lot of research ongoing on, for instance, coding and modulation schemes. And the white paper highlights this delayed bit interleaved code modulation as a potential solution. But also when you go to high frequencies, the importance for access to the network with random access becomes complicated when you have very narrow beams. So here, the white paper explores, for instance, this non-orthogonal multiple access solutions. It also explores different waveforms. So perhaps the traditional OFDM waveform is not suitable at high frequencies. And the white paper discusses this DFT spread OFDM to see how it could be working. Another promising technology is this integrated sensing communication, as we all heard of, where you reuse the radio interface, for instance, as a radar, and then you can expand the network to beyond communication services. So this could either be offered as a service to an end user to have a spatial map of the environment, or simply be used to improve the communication performance if the network knows where different obstacles in the environment are to do proper beamforming. And finally, we have this multi-rat spectrum sharing, which is a continuation of the 5G technology of dynamic spectrum sharing, where you can reuse the 5G spectrum for 6G and dynamically switch the usage between 5G and 6G depending on instantaneous needs. And compared to the 5G dynamic spectrum sharing, the multi-rat spectrum sharing between 6G and 5G would have much lower overhead, since 5G has quite lean carriers compared to how 4G was looking like. Next slide, please. Another aspect is looking at new access and flexible topology. So here we see the need for multi-connectivity. In previous generation, we had carrier aggregation and dual connectivity. And for data aggregation, these two techniques fulfill rather the same role to add the performance of multiple carriers. And for simplicity, we see for 6G, it would be beneficial to only have a single aggregation technique instead of having both of these. So looking at what aspect of these two should be kept and which parts are unnecessary. We also, of course, have the non-terrestrial networks that's been going on in 3GPP to see how we can incorporate non-terrestrial networks with the terrestrial networks. This, of course, to extend the coverage to remote areas and perhaps improve the coverage even in the urban areas. And here we're looking at different architectures, for instance, transparent and regenerative, as is being discussed in 3GPP. And it's still an open question which is the preferred solution. There's also a discussion in the white paper on these so-called special purpose networks. So you have a local network of networks that you can locally optimize for performance, for latency, for redundancy. And the view here is that it should be possible for these local networks to act autonomously, at least during a short period of time, if it loses connectivity to the wide area. Next slide, please. There's also a lot of work on hardware for 6G. And the white paper discusses a wide area of technologies. One aspect is related to high frequency transceivers. So if you want to go to these sub-terahertz or even higher, the current technologies are not suitable because they're not performing sufficiently well or draw too much power. And one technique which is being explored is this resonant tunneling diodes, which shown promising performance in sub-terahertz with the lower power consumption than other techniques. Another aspect is defining these 6G devices and the device classes. So in 5G, we had this mobile broadband, MMTC, and the URLLC device classes. And for 6G, we have explored what different device classes there would be. And one of them is this reliable high data rate with bounded latency. So this is the XR device class where you need both high data rate and some bounded latency. It's not extremely low latency. It should be a couple of milliseconds, but it should be guaranteed that the data can arrive within this limit. The next is this HRLL, which is highly reliable low latency. So very similar to the URLLC, but with less extreme requirement on reliability and the latency. So this is trying to be a little bit more realistic on the requirements, since the URLLC hasn't had much uptake in the industry, primarily because it's too expensive to implement, and the cycles in the industry are a bit too long. So this is trying to look at what is more realistic range of the requirement. The next one is this energy neutral. So as I mentioned before, this energy harvesting. Certain devices will need to operate with virtually no or very close to zero energy. And this will not be able to support normal services, but maybe just for sensors. And finally, we see this enhanced MTC, so enhanced machine type communication, which will be a continuation of the 5G MTC with fairly similar requirements as in 5G. Next, we have some discussion on different hardware accelerators. So, for instance, this smart NICs to be implemented to handle data processing for at line rate, using it for encryption, compression, or, for instance, deep packet inspection to enhance the performance. And there are also work looking at different architecture for neuromorphic computing, which have shown that it's more energy efficient for real-time processing, for instance, deploying these deep neural networks, doing different optimizations. Next slide, please. And there's also discussion on different photonics technologies. And this might primarily be important in transport, or for instance, in the high frequency or sub-terahertz technologies. But one aspect is looking at this photonics-based RF generation, where you have two light sources mixing two lasers, and you get the difference in frequency as a RF frequency. And the benefit of this is that you can get very high RF frequencies up to terahertz, while the tuning range can be extremely wide, from a couple of gigahertz up to terahertz. Unfortunately, it's quite unstable, so there could be a quite large frequency drift, so you need expensive equipment to stabilize this. There's also been some work and discussion on this photonic phase arrays, where you do this mixing at the phase array. So you distribute the signal optically all the way out to the antennas and generate the signal through photonic generation already out at the antenna. And now I hand over to Krisa to present the other slides.
Thank you, Patrick. Hi, everybody. I'm Krisa Payani. I'm the coordinator of the project Desire 6G. And I will say a few things about the rest of the technologies that we investigated within the concept of within the white paper. So network softwareization is not new. It's essentially, it was pivotal in 5G about shifting essentially the functionality of networks from hardware-based implementations to more software-driven ones, leveraging technologies like cloud computing, virtualization, slicing, software vendors, and whatnot. Now, the thing is that of course, in the white paper, we try to identify what are these aspects, what are the elements of this technology like virtualization or slicing, how this should address the unique challenges of 6G. For example, for network virtualization, it is important to extend across, let's say, more device edge to cloud continuum, where we incorporate and we use resources from the far edge, or even different technology domains like non-terrestrial networks, providing a unified and seamless view of the network resources in order to allow end-to-end orchestration and management. And at the same time, we must address, of course, security challenges due to the multi-stakeholder nature of the environment, and also support extreme KPIs that are coming from 6G by managing the corresponding virtualization-induced latencies. In the case of slicing, we need to pay extra attention for addressing the complexity for network slice lifecycle management in this multi-domain, multi-stakeholder environment. And also we need to look into intelligent optimization approaches that are required to avoid over-provisioning resources in the evolving cloud-native systems. And this is the topics that are essentially addressed within the white paper. Now, cloud-native networking, of course, it has been already partially addressed in the previous, in 5G and 5G Advanced. Cloud-native ideas were incorporated, but essentially in the service-based architecture in 5G, it increased the dependencies between NFs, which led also to higher signaling costs and latencies. And this is something that should be tackled within the next generation, along with the cloud-native approach for the data plane. Now, regarding disaggregation, which is for the RAN and the core, which is about splitting monolithic network functions into modular components that can be independently deployed and managed. This, of course, in the case of 6G, we see already that increases the complexity of the system, especially if we consider that we can dynamically select the level of aggregation, while at the same time we must pay special attention for standardizing and defining and standardizing the corresponding interfaces. And finally, in this, let's say, area, deep programmability is about not only is programming the network not only on the control plane but down to the data plane. And there has been already efforts that we see how we can use the data plane programmability or deep network programmability for also flooding network functions to hardware accelerators with eBPF XDP or P4 technologies, or for applying more fine-grained traffic monitoring, or for packet-level decision-making, which is nice because it adds flexibility, but it also brings challenges and problems from the software world, like, for example, ensuring consistency between management, control, and user plane, or let's say addressing runtime, the need that we should address runtime conflicts. So these are also discussed within the white paper. Next slide, please. Now, the edge-to-cloud continuum, of course, refers to the integration of heterogeneous devices and network services that are spanning different network domains, from the core to extreme edge, to the UEs. And these belong to different stakeholders, and we want to make this a cohesive and dynamic framework and dynamic ecosystem for service execution. However, because of this diversity and this difference in the stakeholders that control the resources, we need to have a very effective management and orchestration framework that will be way more complex than in 5G. And there we discuss in the white paper how machine learning techniques are crucial for handling this complexity, while adopting cloud-native principles is fundamental for ensuring flexibility, scalability, and resilience. Network softwareization, we talked already about it. However, we need to take into account that the mechanism, like, for example, the coupling, the tight interactions between functions, or cloud-native service adaptation, for example, are not in the same level for networking as it is for cloud computing. So in that sense, we need to kind of redesign networking functions for a serverless paradigm. And this is the direction that we're giving in the white paper. Moreover, the fact, again, as we said, we have a number of multiplicity of new resource types with specific interfaces, with specific capabilities and characteristics. Now, to use them, the management and orchestration framework must be aware of these capabilities, of the specificities. Like, for example, what kind of hardware acceleration can be supported, if it can be supported machine learning workload. So this moves them between the typical abstraction of interconnected computing nodes. Therefore, we need to be able to use an advanced abstraction layer that will include hardware and virtualized resources that can account for the device features, for the unique device features, and will enable real-time adaptation and resource of the service, and of course, resource optimization. And that implies also efficient offloading with appropriate APIs that will be provided to the developers, designing or thinking about resource-aware and mobility resilient offloading mechanisms, and jointly optimizing the resources and application performance. Now, last in this category, as we're thinking about the edge-to-cloud continuum and how we can utilize them, of course, federation is very important because it will enable multiple operators and cloud providers to collaborate dynamically while maintaining the individual administrative control over the resources. And this is more important for 6G services, like, for example, real-time augmented reality, that require handovers or operation across various network and computing domains. Therefore, we need to address specific challenges and new challenges that are pertaining to interoperability, to security, to privacy, and this through robust federation frameworks that can seamlessly integrate diverse technologies and services, and in many cases using machine learning for allocation and security. Next slide, please. Now, about network intelligence, it essentially refers to the integration of machine learning throughout the network design, deployment, operation, and maintenance, enabling, in that sense, automation at all levels of the network. And the concept of AI native 6G architecture essentially represents that exact paradigm shift in telecommunications, where unlike what we had in 5G, where AI was essentially an afterthought, AI native networks here integrate AI into every phase of the network. So what are the key features of AI native architecture? Intelligence everywhere, where AI is embedded across the network, enabling adaptability and new functionalities. Seamless availability of the data and processing the data across the network to ensure efficient machine learning operations. Zero-touch management, where autonomous networks operate with minimal human intervention. And AI as a service, where we can use machine learning models, tools, and data sets that are provided as services through appropriate APIs. And we see already that in this direction, AI solutions have impacted the radio, for example, the 6G radio interface, enhancing its efficiency, for example, from MIMO operations or signal optimization or whatnot. Well, we see also advances in higher layers in the protocol stack with solutions on machine learning-based solutions for MAC protocols, resource scheduling, and so on and so forth. Moreover, we see also, and we expect that 6G networks will integrate mechanisms that will support decentralized intelligence, where machine learning models will be trained and deployed or distributed or extreme edge devices to manage the analysis and the data as they're generated and to ensure scalability. And as an example of this, we have, for example, federated learning for RIS. We already have seen IBM working or, let's say, deployed for mobile networks, but now in the white paper, we're discussing about AI for IBMs, how utilizing AI and intent-based networking can further simplify network operation, optimize its performance, make it adapt more to dynamic requirements in real time, interpret intents more easily, and so on and so forth. And finally, the most very important aspect to support network intelligence is, of course, to get data at different granularity and timescales, ensuring that it's collected, processed, and analyzed efficiently in order to be able to enable to support decision-making. Hence, what we need multi-tier storage architecture, granular access control to manage this massive, let's say, data efficiently. This is also discussed in the white paper. Next, please. Finally, to close the closing, let's say, topic is about network digital twins. Now, digital twins, you all know that this is essentially for the network, they create digital replicas of the physical network with a goal to accurately reflect their property and behaviors. And for 6G, they're considered pivotal. Why? Because we can advance further network automation and intelligence by enabling a more precise and near real-time representation of the network state. Now, we expect, and it is discussed in the white paper, that network digital twin will be integrated into the orchestration and life cycle management process as a sandbox environment for decision making. Thus, what does this mean? That it has additional challenges because it must be customized with different levels of granularity for different timescales to include the properties and behaviors that are relevant for each use case and reflect the technological domains for 6G. And there is a number of different challenges, of course, that need to be we need to face, from generalization to composability to how we collect the data and transfer the data, explainability of the decisions that are taken, and so on and so forth. And so these technological enablers, the ones that Patrick mentioned and the ones that I'm trying to explain, essentially, some of them existing and basically evolving from 5G, and some of them more new, like the incorporation of the network digital twin, are what we consider as the building blocks that will also drive the requirements for the 6G system architecture. So back to you, Carlos.
Thank you, Krisa. Thank you, Patrick. Now we move to the chapter 4, 6G architecture. And I now pass the floor to Omer.
No, it's Morten.
Oh, Martin, sorry. Yeah. Martin first and then Omer. Okay, sorry about that.
No problem. Omer will come in a couple of slides. So I will start here. This is then the architecture. Yes. And I hope you can hear me. Anyway, my name is Morten Ericsson, and I'm the work package lead in the architecture work package in Hexa X2. Okay. And then you saw the authors there also, so yeah, maybe we can skip that for now. But there were other editors here also, Chi and Marco, and then Omer for this chapter. We started off by looking into the IMT 2030 use cases or usage scenarios, and identified that 3 of them are basically then the 5G, enhanced mobile broadband, massive MTC, and your LLC, and we grouped that as extension, the green part there. And then there are new usage scenarios, ubiquitous connectivity, AI, and communication, and integration, and sensing. So that then becomes 4 different usage scenarios. And then we ask the projects to contribute to these different areas. And the first, you can't flip here, I think it's an animation. Yes, thanks. So the first question we ask the project is to what are the challenges here for these usage scenarios in 6G? And the second question is what are the vision for the innovations? Actually, solutions, you could say, but sometimes we talk about visions here more than solutions, a more generic term perhaps. And these I also want to say that we have a little bit overlap, of course, with enablers, but here we focus a little bit more on the architecture. But I will start showing off the challenges here, and then maybe the overlap is even more. But we try to talk more about architecture here. So next slide, please. Then we start with the extension, the green part here, which is then a continuation of 5G basically, and how we can improve that. And the bullets there to the lower left are then a couple of the challenges, and I will not go through every one of them, and they are even more in the white paper. So I will just talk a little bit about some of them. So, for example, the first one is then the RAN virtualization. The virtualization is ongoing, and it's an important topic. I think it's someone maybe can please try to mute. I hear some noise at least. So the RAN virtualization is of course, and the virtualization in general is ongoing, but it's not really sustainable. So we need to have better the hardware accelerators, for example. We need to have better solutions for this, and there need to be an architecture to support this also, of course. That was also talked by in chapter 3 by Krisa and Patrick. Another thing is then configurable multi-connectivity in general. It's even though it was we have a lot of complexity in 5G regarding the multi-connectivity, it's still a little bit lacking flexibility. So we need to do a little bit both there. It's a challenge to fix that. Then another thing is the integration of localized network, and that may be reflected. This is maybe the network of networks, I think, we're talking about a couple of slides ago. And that's a figure example illustration. There is maybe this network of networks. Here we need to, I think we did a good work with these sub networks and then to integrate new networks in 5G, but we need to enhance the support for new networks such as NTN and sub networks, in vehicle networks, collaborative robots, as Toon talked about, indoor factory networks, whatever. So that's an important challenge that we still have to work with. And then the end of the last bullet, growing energy consumption, and this is specifically the radio units part, the radio part. I think that improved quite a lot in 5G compared to 4G. So that was better, but due to the increase in traffic, we still see an increase in energy consumption. That's still a challenge. So that was the extension. So let's flip to next challenge. That is ubiquitous connectivity, which is then the new one of the new areas in IMT 2030. And the ubiquitous, this is to connect on unconnected. I think you see in this definition that more global coverage. So I added this NTN figure because maybe to illustrate this. But it's not only about that. We have a lot of wide area. I still hear a little bit noise actually. So please, can you try to mute? I don't know who is it, what it is. It's a little bit annoying. So if someone could identify the noise, please try to mute them for me. Carlos or Mikko or someone. Anyway, so here we also have a lot of different challenges. One of the first one is this, that we lack a good APIs for this, for the ubiquitous connectivity. We lack this global, open, easy to use. There are work on this in the 3GPP. We have the Camara and Seal, but they haven't taken off. Or maybe things take time, but maybe it's because they are rather complicated. But this is the work maybe to investigate if there are ways to do. Now it's clear for me. Thanks, Mikko. And the next one is then the terrestrial network and the NTN integration. It's the third bullet there. That's of course we need to integrate NTN from day one in 60. It's always we try to integrate the NTN at after the standard has been done, and I think we need to do the opposite now to really integrate it. And there's a lot of in the white paper we discuss a lot about improvements in this area also. So but that comes later or maybe presented. Then we have another one worth mentioning here. So that's a management plan centralization. So that's about, in particular, the centralized slice management, and it's not really scalable. And that's something we need to update in 60 to have it more, so it can work for scale for multi-stakeholder ecosystems. Going on, you can flip next slide, please. So here we have the AI and communication. And the first bullet then is enable AS is a data-driven architecture. That's maybe the whole idea here, to have an architecture that can handle all parts of an AI data-driven architecture. We need to have the AI should be used in network and also for external use. So we have to expose it. We need methods how to update and train the models and process and to access the data and so forth. And we also have to optimize this, the computing resources for this. It's not without cost. So we have to be efficient here and learn how to do it in an efficient way. And how architecture for trying to optimize this also. And then a little bit the same thing here is that this is efficient application of AI ML algorithm. And that's about how to achieve these realistic data for third-party developers, for example, so they can use this realistic data to develop new AI ML models for their application. So since the data is usually owned by someone, operators or application owners, so it's not that's a challenge there, how to solve this actually in a secure way. Another thing is then this last bullet, need for self-evolving autonomous extendable system with predicting capabilities. I think maybe the longest challenge title of all. That is then we need, it's a challenge, we need new ways to predict and enhance traffic performance, and also to support the self-configuration and network automation. It's a lot of words. Network automation basically, and also to use this for better traffic performance. Next slide, please. Integrated sensing, overlapping a little bit what Patrick and Krisa said here. We need a architecture then to support we call beyond communication. So it's not only sensing, it could be compute offloading also, of course, and maybe even other services coming up in the 60 timeframe. But there's of course, I think 5G made a huge effort to introduce this massive communication in URL LLC, but of course we lack support for sensing in real way. You could do some sensing in 5G perhaps, proprietary solutions, but it's not really super efficient. And that goes also this high data volume is about that. So if you do sensing, you probably, as if you do it in 5G now, it will be very inefficient. Will consume a lot of the data is needed to overwhelm the system with data. So you need to do something more smart in the architecture here to handle the distributed sensing services. And there's also several lack of sensing, and that's of course lack of sensing control functions. Yes, there are. We need some sensor functions for this. And we need also another thing that's interesting here is maybe lack of continuity of services over a large area, and that's an interesting way. How do you follow an object over different cells, or for example, and last but not least is the power consumption here is also of importance. So next slide. I think it's the last one. I think. Oh, now I think I'm done. So let's go. I think it's you, Ömer.
Yes, Martin, thank you. So here we see first of all the architectural foundation that we have set already at the end of the 5G PPP. This is the foundation that we start with the SNS program, and then based on the latest work, basically we have looked at the architectural trends and also like the vision for the architecture innovations. So next, please. So the first of all, we have the AI-powered immersive communication. Here we talk about some examples include here are for instance, the support for immersive XR. An example here is the holographic teaching. Then optimization for the resource allocation for joint computing and networking, as well as the analytics engine, for instance, where we can predict the network capacity needs to ensure quality of service guarantees. Next. So ubiquitous connectivity. So here we have the vision of more seamless integration between TN and NTN, where we might have multiple different access technologies, and we can utilize the multi-connectivity in a unified way. Another example here is the reconfigurable intelligent surfaces, for instance, which can be used for coverage enhancement. Next, please. So for dependable and resilient communications, we are talking about the move to more from the deterministic communications toward more dependable real-time communications, which will necessitate the efficient use of network monitoring and time-critical automation that's associated with such networks, and the utilization of multi-domain and multi-technology deterministic communications. This would include, for instance, the TSN-enabled 3GPP and TSN-enabled Wi-Fi. For the case of predictable packet delay as an enhancement, where we characterize the stochastic elements in terms of the latency performance, this enables us moving towards more dependable and resilient communications in the 6G time. Some other examples here are related to the in-X networks, where, for instance, in an in-car subnetwork, we can replace the wired communications with the wireless communications that, for instance, can reduce the weight of the cars. Next, please. So for the sustainable massive communication, some examples are given here, such as the low density, low Earth orbiting satellite constellation for massive IoT, utilization of the disaggregation to, for instance, collocate UPF and CU, and the usage of GPU-based acceleration for DU and RU offloading, so to further improve the energy efficiency. Next. So for secure, reliable, and trustworthy AI and communication, we, for instance, some examples include the utilization of network slicing against certain attacks, so which is kind of considered as a mitigation enabler. Post-quantum crypto is one of the highlights to be considered for the 6G systems, even starting from the 5G systems. Federated learning-based anomaly detection, and also utilization of AI for security analytics. Next, please. For integrated sensing and communications enabled 6G networks, as also Martin presented in his slide deck, we are looking into enablement of new use cases, such as the beam tracking and the vulnerable road user sensing, and as well as the joint usage of sensing and RIS operation, for instance, to improve the RIS operation. Next. So as the overall vision of 6G is the fusion of digital, human, and physical worlds, we also look into the lessons learned and the technology gaps identified by the 6G trials. So that's also part of to shape our overall architecture vision. Next. So what we have done based on all the architectural trends and the visions for different innovation areas, we have categorized all the technology enablers under what we called innovation areas, and we have mapped them on the foundational architecture. And this is how the different innovation areas would impact the architecture. This is our kind of like our starting point. We further will work on the details and how these innovation areas will shape the overall system architecture. So one example here is the innovation area number 3, service awareness. We know that there have been quite some activities in terms of providing the exposure framework, such as the CAMARA and the CAPIF that we know from 5G times. We also believe that 6G system should include a generic exposure functionality through simplified APIs and so that we can expose the capabilities for communications and beyond communications features to the end-to-end applications. Then the other example here would be the network simplification. So in terms of network simplification, we know that from the 5G times, quite some options were specified in 3GPP, but only too often were deployed at the end. So we think for the case of 6G deployments, we should avoid specifying many deployment options. We should focus on the needs for the initial deployment of 6G, so day one requirements. We should simplify the protocols and so that minimize the signaling overhead between the access node, as an example, or between the UE and the network. One example is the segregation here between the CU and DU, and the extensive inter-node signaling should be avoided as part of the network simplification. As a third example, we have the support for dependable communications. So we are, as mentioned in the previous slide, as a vision for 6G, we are moving away from more deterministic kind of communications to more dependable and resilient type of communications, where the 6G system design should consider it for the elements that are deployed. And also there should be the enablement of provisioning of the configuration APIs toward the 6G network players, such as the operators. And the last, but not the least, we have the innovation area number 9 for the TN and NTN integration. Here we are talking about the support for near unified 3D multi-layer multi-connectivity paradigm and potentially enabling direct-to-satellite connectivity. So these are just some example innovation areas that we have captured in our white paper. For the rest of the innovation areas, you can refer to our white paper. Yeah, thank you.
Thank you very much, Omer and Martin. Now we will move to chapter 5 on the major differences with respect to 5G. Bahare, please, the floor is yours.
I think I'll take Bahare's floor instead.
Oh, okay, Carlos, okay,
speaking.
sorry.
All right, no problem. So yes, this is chapter 5 is about major differences with respect to 5G. After the extensive presentation of research areas for 6G, we thought it was a good idea to try and summarize or highlight what the key technologies are or the major differences are. And this is what this chapter is about. So next slide. First one is devoted to explain where those major differences stem from. Well, you can see the circle about the new capabilities of IMT 2030 and the enhanced capabilities for IMT 2030 as well. And as you can see, the blue color, I mean, it's a substantial part of the circle. So there are many new capabilities that are expected to be fulfilled or provided by IMT 2030. And if we have a look at the KPIs for 2030 versus 2020, that is 6G versus 5G, in some cases, KPIs exceed by more than one order of magnitude. For instance, in the case of peak data rate, latency, and reliability. So this means that KPIs are significantly more demanding than those of IMT 2020. And on top of that, 6G is also called to support a selection of the United Nations Sustainability Development Goals, which are the ones highlighted in, say, colors with respect to the gray ones, notably those focusing on sustainability, inclusion, trustworthiness, and so on and so forth. So that's a lot of work. And this, of course, requires the integration of new technology components, key innovations, we call them. And the ones that we will be presenting on the next slide will revolve around radio access and core networks. Next slide, please. And here there is the short list. Of course, it has to be necessarily a short one. There are many others, but we try to focus on those that we consider which are, say, key game changers for 6G. If we focus first on radio access networks, of course, it's out of that AI native interface designs are one of the key innovations to be provided by 6G networks. Everything started already in release 18 with dedicated studies about how new functionalities could benefit from AI/ML, such as channel state prediction or feedback or beam prediction or precise positioning. But 6G networks are supposed to go one step beyond and natively incorporate AI/ML in order, for instance, to learn new waveforms, match the propagation conditions or hardware impairments, limitations, etc. So that's one of the key innovations in our opinion on the RAN side. Integration of multi-access edge computing with HAI. It's also a challenge because of the specificities of edge networks encompassing many nodes, distributed ones, and in some cases with some limited power. And you have to make both things work together in order to be able to provide the necessarily features, capabilities for novel services like advanced robotics, which were mentioned some time ago here in this presentation, or immersive virtual reality or augmented reality experiences. So that's also an important aspect and a key innovation in 6G. Next, about frequency ranges. 6G indeed will need to utilize a combination of various frequency ranges in order to meet the coverage and enhanced capacity requirements required for that. Still, frequency range 1, that is sub-6, and FR2 will be important for sure, but there is a new band, which is frequency range 3, is the upper and the lower mid bands, sitting more or less in between FR1 and FR2. And this is a band which has lots of interest from major players, notably vendors, because it balances the wider bandwidth, which can be provided by FR2, with the better propagation properties of FR1. So this sounds like an interesting trade-off, and this is something that it's likely to grow in the years to come. Actually, work has already initiated in the last World Radio Conference and will continue in World Radio Conference 2027. As for terahertz communications, another key technology, offering fast bandwidth and spatial resolution, which other bands cannot offer. However, this is probably a more longer-term feature of 6G, because also economic constraints that a massive development of terahertz would entail, and then it's probably FR3 and FR1 that will come in the first place. Still, terahertz communications open the doors to using to packaging more antennas into a given aperture size, that is to form extremely large antenna arrays, and also by this enabling near field communications, where the concept of beamwidth, the beam, sorry, is not there anymore, but just placing energy in specific locations in the 3D space, and by doing so, spatial multiplexing can be improved and interference also reduced. So that's a new paradigm shift from 6G. And finally, and also in the radio access network part, well, there's ISAC, integrated communications and sensing, has been already mentioned a number of times by the previous presenters, but this is a game changer. I mean, doing everything, communications and sensing with a single signal, because this allows to enhance existing services with location and contextual-based information. It's providing additional value to 6G systems. On the core network side, again, AI/ML integration, a seamless integration of AI/ML in the core network will allow improving the levels of efficiency, security, and intelligence, and also dynamically managing network resources, and also getting deeper insights into network traffic and user behavior. That's also a very, key step towards 6G that could be taken by incorporating AI/ML in the core network of 6G systems. Then architecture has also been robust and future-proof. These are already a number of works, and lots of research has been undertaken in the SNS JU projects from phase 1 and phase 2, and this is now finding its way towards standardization next year. As for futures for slicing, 6G is probably headed for slicing with enhanced granularity beyond that provided by classical 5G services that you can see listed there. And in order to achieve that, a deeper AI integration for this slice management will be required. And finally, to conclude, that this core network will have to support a range of innovative technologies, integrated communication and sensing, among many others, and this also calls for the key innovations listed above to be introduced in core networks. And that's it from our side. Happy to take questions in the chat, if any. Thank you.
Thanks a lot, Carles. Now we can move to the last chapter of the white paper on next steps. Aurora, Valerio, the floor is yours.
Thank you very much, Carlos. I trust you can hear me. And so good afternoon, everyone. My name is Valerio Frascolla. I work as Director of Research and Innovation for Intel. I'm based in Munich. and I have had the great pleasure to collaborate with a set of colleagues from the 6GIA Association and other companies in order to deliver the Chapter 6 next steps, and especially have done that together with Aurora Ramos from Capgemini, with whom we are splitting the presentation. So what does next steps mean, actually? We have been talking a lot about technology, about vision, but you know, in order to launch a product successfully in the market, you do not only need to have excellence in technology, but you need also to take care about additional aspects, and these that are not specifically technology aspects, and this is the focus of the presentation. So next slide, please, of this chapter in the white paper as well. No, it's the previous one. Yes, exactly. Thank you. So it's important actually to say that the 6G standardization has just started. In reality, it will start with release 20 at the beginning of next year and will last several years and will come in phases similarly to what we experienced in the evolution of 5G. As you remember, there was a phase 1 and phase 2 and then 5G advanced. A similar approach we will witness also with 6G. And as you have seen from the previous colleagues, it's a very complex system of systems. And as such, the standardization effort will need to be provided by different standard development organization, SDOs, like 3GPP, ETSI, ITU, IETF, and IEEE, and others. And it's also interesting to notice that there are other fora that are taking attention in the ecosystem worldwide, like, for instance, the Open RAN, that focuses specifically in optimization of use cases and on AIification of the different block of the forthcoming 6G architecture for end-to-end services. So it's a package of different activities that span several SDOs that are to be taken into consideration when talking about 6G standardization. However, even though there is a palette of stakeholders, let's say, the two main ones that we can identify are indeed 3GPP and ETSI. The outcome that is expected by these two SDO is the first technical reports. Basically, these are docs describing the technology, are expected within 3GPP already in release 20, so probably between the end of next year. But the first normative document, the technical specification, which is actually the text that each product will have to be compliant to in order to be sold as 3GPP compliant, will not come before the end of probably release 21. It means in a time frame that at the moment we can judge between 2027 and 2028. To help this complex standardization effort is key one thing: to jointly work in a pre-standardization environment with different stakeholders of the system, equipment manufacturing, device manufacturing, and operators, all the main players of this complex ecosystem. And these activities are taken care of, for instance, in pre-standardization activity in the different European associations like 6GIA, but also IoT, BDVA, and others that are to be considered when these discussions are held. Anyway, we are proud to say as an association that the pre-standardization work group has done a lot in order to synchronize and do a pre-standardization work before the real contribution can be brought into standard. Next slide, please. So in this figure, maybe it's a bit small, you will have the pleasure to have a better look at that in the white paper. We wanted to sketch a time window that span a decade, basically, where you see at the top the 3GPP supposed releases 18, 19, 20, 21, and 22. And as we said, 6G will start with release 20 and will move over with the other releases. And then ITU cycles, that it comes basically in three main chunks: the vision framework, the requirement and methods, and then the proposal, proof of concept, and stuff. So you will see that this needs to be synchronized between the green and the blue. But in addition to that, we wanted also to stress the constant work underpinning this huge effort of standardization that is driven by us, by 6GIA, but also by other fora, by other associations, and by other standards, as listed in the central part of the figure. In the last part of the figure in orange, you will see some check mark for us to showcase what we will able as a community to create, like 6G proof of concept or pre-standardization come together. For instance, the UEFA Euro Championship or the FIFA World Championship or the Winter and Summer Olympics. We did the same with 5G, and it is expected that the same will come with 6G. So these are check marks when we are going to, as a community, showcase some pre-6G systems. And finally, it's worth mentioning the Horizon Europe as an SJU that has come with a lot of money on the table for us ecosystem to enlarge our capability to deliver on 6G and pre-6G activity. And as you know that there are a set of calls that come in different phases. You will have additional information in our website. And then, of course, the 6G network and services comes with overlapping interesting activity that are related to all of the above. For instance, the first experiment that were issued in the Horizon 2020 already project that started working on pre-6G topics, and then the trials and pilot, and then finally the 6G deployment and commercialization, which will be actually the moment when real devices and network will be launched into the commercial markets. Next slide, please. So I mentioned standardization, but regulation also is a very important aspect to take care of. As we want to have a system that works worldwide, regulation plays a key role in its rollout, right? Because we want to have services that work in cross-border environment, of course. And of course, personal data management, as you know, might be treated differently within even different member states of the European Union. You can think of the differences between, let's say selling something in India or Korea or North America regarding how the data will be managed. That's why it's very important, you know, that data monetization is coming to the forefront, and the way that the privacy of the data, of personal data, is handled is becoming a more and more important point. And regulation help us as an ecosystem to understand how to better frame these key aspects. To establish a fairer and citizen-focused market, you might know that the European Union has already issued a set of so-called acts under regulation. And these acts are not carved in stones. These are documents that have been drafted, also taking input from the ecosystem, from the main players and from the politicians, from the member state and from the industry SME, and will evolve in time. So we have to have a look at those and the evolution of those documents in order to design and develop 6G technologies. Which are these acts? Well, there are some very well known ones like the AI, the Data, the Cybersecurity Act, but also there are others, maybe not so much known, like the Radio Equipment Directive, that is key in order to be able to launch a product in whatever market, specifically in an EU market. There are other aspects to be considered as well. We talk more about that in the chapter. For instance, the digital product passport is taking a lot of attention from the legislation point of view, and its implication on all services and devices sold in the EU will be another important factor. But in general, also, not only the European Union is issuing regulation, but also other entities and other countries outside of Europe. And therefore, we have to have a look and take also that regulatory part into consideration moving forward. And with that, I hand over to my colleague Aurora. Next slide, please.
So thank you, Valerio. So this is Aurora Ramos from Capgemini Engineering in Spain. So let's look now on the more related business aspects of these next steps. Some of the topics, of course, have already mentioned, but let's look on what is next in terms of, business related roadmap. So first, we have seen from the use cases and also introduced on chapter 2 by Håkon that we have in 6G a much more convergence between the application and the network itself, the vertical application and the network. This is something, of course, you all know that it started in 5G, but most probably not as much as covered as initially expected. Now in 6G, we really see that the 6G network turns into application platform with these more service-oriented paradigms, with business models as network as a service, in which we really make easier to the vertical providers the access to the network capabilities, hiding these difficulties, expressing the requirements through intents, and so on. Second, which has been mentioned as well, the very high distributed approach that we have in 6G for the services involving multiple distributed cloud providers in which we will be deploying both application and networks, and also this expected chain of federation, more and more of the network operators aligned with the 3C networks concept on connected collaborative continuum in this multi-stakeholder, let's say, kind of large scale, somehow ecosystem. That will be needed, will take us to evolve new multi-providers business models. This was also, there was some discussion in the chat as well. We probably need to revisit some of these relations and establish these new business models. Third bullet, we have could be seen as a subcase of the second one, of the previous one, but it deserves its own, let's say, mention, and it's coming from the integration from the terrestrial networks with non-terrestrial networks, as we have seen a key differentiator in 6G. We are seeing that MNOs and satellite network operators are already interacting, for instance, in the context of the standardization bodies on 3GPP to actually work in this integration. But we still need to go into the details on the business models to make this a reality and things working. Four, there is an important ongoing trend on open networks and open architecture and interfaces that will bring new, let's say, different view on the innovation, right? Operators could be able to select from more diversity of solutions, but at the same time should be interoperable to improving the operational efficiency. Then sustainability. You have been heard about sustainability through the whole white paper presentation. It's really a key differentiator. But as it was mentioned, it's not only about making CC sustainable, but looking at the business perspective, is that 6G will be also acting as a catalyst to improve sustainability in the other vertical sectors, which will have its business implications as well. And finally, as AI is becoming an intrinsic part of 6G, as we have seen, and also in the technological enablers, we see that data is becoming a key factor of production. Businesses need very strong data frameworks that assure integrity of the data and scalability and so on. Next slide, please. Then finally, looking at the main challenges ahead that we identified, we see that Europe has a strong position in terms of network infrastructure, with two of the three world leading vendors with their headquarters located in Europe. But given these evolved value chains that we have seen, we tend to see that the market share or the revenues of the European operators could be decreasing somehow, given the competence of the non-European hyperscalers or online service providers. So we take the view that a better market balance should be looked for, involving the principle of same rules for same services, even dedicated resolutions mechanisms to ensure fair commercial outcomes. Also, we have seen that these very important technologies, AI and cloud technologies that are key in 6G, need to be more taken into account for Europe to maintain their European technical sovereignty, let's say, because there are technologies that maybe we are not so, let's say, they are not so prominent in Europe comparing with other parts of the region. So we take the view, and we are in the process to do so, to reinforce these capabilities. Also regarding the end user devices, so a dedicated effort with chipset technologies, we advise it will be also very recommendable. Regarding human resources capacities, also pushing the risks that combine these technologies in the same profile, computer science, cyber, AI, and so on, it will be very beneficial. Finally, in the box, regarding the specific challenges related with sustainability, we have identified mainly 3. The first one is related on how we measure and assess sustainability. And this should be applied, as I said before, in the 3 dimensions: environmental, social, and economic. On the environmental, it might be a bit, let's say, more straightforward with measuring, let's say, energy efficiency, decarbonization of CO2 level, but this should be also looking at social and economic. This is something that we are working, I would say, extensively in Europe with XIX projects and other projects, establishing an important methodology to transforming these KPIs, value indicators, in KPIs that we can measure. And you can also look at previous positioning paper on the 6GIA last year that extends also these aspects. Second, the integration of sustainability in all the 6G services in a default manner. And finally, handle or unveil these trade-offs of finding between the sustainability goals and with the technological and economic efficiency, which is a very hot topic that it will need, in our view, a lot of attention in the following times. And with that, I go back to Carlos and Miko for the closing. Thank you.
Thank you very much, Valerio and Aurora, and thank you all the chapter editors for the presentations. We are at the end of the webinar presenting the white paper. I think there's been a lot of very interesting discussion on the chat, and as we have notified during the webinar, the white paper is already available on the 6GAI webpage. You have a link, and we will be also providing the slides because there was also some questions about that in the chat. And Miko, I don't know, you want to do some final closing remarks before we close the webinar?
Yeah, I would like to say thank you to 6GIA and thank you to all those contributing, cooperating to make this happen. Has been a great effort, and as you heard, so now you can download the end results and the slides a bit later, but they are also made available. So with the process with 6G, we are aiming at this one global standard, unified approach globally. And for this, in addition to the discussion in Europe, we of course need the worldwide interaction, which is strongly taking place. And you saw many examples and more detail of that in the presentations. One thing also widely shared here through the presentations was the sustainability, looking at all the different aspects of environmental, social, and economic sustainability. And this important target for us, matching well with European values. So thanks a lot for attending and the lively discussion also in the chat. Any additional ending remarks, Carlos, or shall we start closing it here?
Yeah, just to say also thank you for everybody attending, and of course to 6G AI, and I think we can close it here. Thank you, everybody.
Thank you.
Thank you. Bye.
Thank you. Have a good evening.
Bye-bye.
Thank you.
Thank you.
Thank you. Bye bye.
Bye.